We build somebody up only to destroy them. Build up Newton, shot down. Dang, I can't talk. Build up Maxwell, gonna get shot down. Same guy.
Okay, so why did they teach you mass attracts mass in school if they've known it's been wrong for 106 years?
Because fundamentally, it's a question of semantics. Because it's difficult to explain. So I assume you've heard that warps space time, right? It's a complicated.
It's not semantics, man. It's two
Huh?
different things. It's not semantics. First, it's mass
So,
attraction. It's a force. The second one, it's a bending of concept.
right. So,
Right.
yeah.
Well,
Okay. So there's a difference between Newtonian and Einsteinian, and I see that you're saying that your argument now is that it's only semantics. Okay. So I'm going to tell you the difference between the two. A Newtonian, you got spooky action at a distance, instantaneous action at a distance. And
mhm.
Einsteinian, nothing moves faster than the speed of light. A Newtonian, you got 3 space, and Einsteinian,
Not
you got 4 space. Right? So these are completely contradicting theories. They don't line up at all. They might line up mathematically, right? But as a theory as a whole, and it's not a scientific theory because you still haven't provided a valid hypothesis. Everybody believes in gravity, believes that it's Einsteinian. So I'm going to ask you again, why were you taught the wrong thing on purpose? I mean, I know it's expensive to update, the science books, right? But you figure they might be able to update them like more than once every 106 years, right? So why did
Uh-huh.
they teach you the wrong thing on purpose?
Because it's really difficult to explain to a 10-year-old kid quantum mechanics.
It's difficult to explain to an adult how the
Yeah.
bending and warping of space-time, a mathematical concept, affects reality. Because think about it like this. I have a concept of liberty as a Texan. Can you bend and warp my concept of liberty?
No.
Okay.
But I hope
So
so.
you have a concept of bending and warping of space-time. Do you think that
Um.
excuse you?
Jesus.
Okay.
Yeah, so you got the bending and warping of space-time concept, right?
Mhm.
That exists in space, right? Where it's a near perfect vacuum where there's no material. So this non-material concept of space-time, it's metaphysical because it's not physical. It's not made of mass, right? It's not made
Yeah.
of matter, material,
You're right.
right? There's no trampoline mat in space, right? It's metaphysical,
Mhm.
meaning that it's a mathematical concept. And when people say that, it's affecting reality, right? This is a logical fallacy, right? Because you're adding concrete to a concept. You're adding concreteness or reality to a concept. Would you agree to that?
Yes, I would. You're absolutely right. And it's difficult for a lot of people to understand, but any scientific model is only trying to describe reality. We don't know that for a fact it is reality. We're just trying to describe reality as best as we can. And for scientists, that's the Einsteinian model. That is what right now describes physics like as well as we can.
I
But
would say it's incorrect because we have much better experimental science with um, quantum physics because we can actually do experiments with quantum physics. So do me a favor, Google specific gravity. Google that real fast.
dang, we just went from quantum mechanics to specific gravity.
That's okay,
Wait,
bro.
didn't you come in saying like talking about like the Cavendish experiment or something like that,
I did,
and
yeah.
Yes.
Yeah.
talking about mass attracting mass, and now you're saying that
Yes.
okay, because it seems contradicting.
Pretty much, yes.
So, okay, if everybody will just let me talk. So, Newton is like the gold standard for hundreds of years. And then Einstein comes along and he's like, wait, this is slightly
Mhm.
inaccurate, but very inaccurate at small and really big levels. And like
Mhm.
small means atoms, right? So,
No,
I,
he didn't say that it was just slightly inaccurate. He said the geometry was wrong, the inertial reference frame was wrong, everything was completely opposite. It was completely different, completely antithetical, and doesn't work together.
you're right. So,
And he got rid of the ether.
was that him? I don't know. Okay. So the thing is, I'm trying to get my thoughts in order. So time, space time, those are all really difficult concepts for humans because we don't have to deal with it on a daily basis.
Smile,
So,
I can help you with something.
mhm,
Because time, space, now, gravity, everything. Because this is flat Earth server. And it would be nice to come back to the Earth and realize, oh, what is going on with the Earth in the end? Is it spherical or is it flat? And we did some measurements, and the math is not matching. That's the point.
uh,
Because in nature, if we have sphere, if you see on TV, if NASA show you, if you can see that in live stream,
mhm.
that mean that in nature also, outside, it's also curving. Is it?
Sorry, what? If you can see a sphere in nature, you can see.
If you can see the sphere from on TV and NASA showing you, from the space, that
Oh
means that
yeah,
also on the ground it's also spherical.
no. Why would it
So
be?
have you switched?
Yeah.
You said to let you talk, and you switched to Einstein. Can you see where I posted at 38 minutes past the hour?
I did.
Einstein's field equations can't solve for more than 2 or more masses. So the math doesn't even work out with Einstein's field equations. So I asked you to look up specific gravity. Can you look it up this time?
I did. Yeah, I already had, but
Okay, so you know it's relative density, right?
yep.
So I got an experiment for you.
Mhm.
So let's say you put an apple in a container, a fresh apple, right?
Yep.
So I'm going to say that the relative density is the cause of it going up and down,
Okay.
sinking and rising. So you add water, right? You change the relative density in the system. Let's say it's a fish tank, right? And then you take away the water. What happens?
Uh, Apple falls again, right?
Why did the apple fall?
According to my model.
No, according to reality. Why did the apple fall?
Oh well, you can't define reality. That's basically unknowable. But
No, bro, listen to what I'm saying. You got an apple in a fish tank. It's floating. You take the water out. It falls or it sinks. What was the cause of the apple sinking?
I really don't know what you want, but I'm gonna say gravity.
Bro, in an experiment, you manipulate the independent variable, the cause, and you witness the effect. If you
Mhm.
manipulate the medium and then you see the effect of it sinking, what was the cause of the
Oh, you.
apple
Oh,
sinking?
okay. Never mind. So the apple's relative density is the cause.
Right. The atmosphere couldn't hold up the apple when the water was removed. It caused it to sink because of the relative density. So this is experimental gravity, gravity that you can verify with an experiment. So what is the cause of everything except for like birds and aeroplanes that use aerodynamics? What is the cause of everything rising and sinking here on Earth?
I guess
Relative
you want
density.
relative density. Yeah.
Right. And you can verify this, right? Because you can boil water. What's going to happen when the water changes state from liquid and becomes extremely buoyant? What happens?
It'll
When it goes
evaporate
to the,
and
it
it'll
goes up. It goes up. And then when it collects, right, because of static electricity in the clouds, what's going to happen?
it'll fall
It's
again.
going to go, it's going to go back to liquid state and it's going to fall. So there's the real gravity. You can
Beep,
verify
beep,
it. It's
beep, beep,
testable.
beep.
It's repeatable. Thank you. Come again.
Yeah. So, I mean, the globe Earth model does the same thing, except that they say that relative density isn't the direct cause. Instead, it's gravity that's the direct cause, and relative density is what determines whether it'll go up or down. Because so if an object is less dense, it'll get it'll get less attracted to the ground per unit volume than the heavier substance, I guess.
So you just said that gravity's involved. So after I just did everything, you just said, wait a minute, you forgot gravity. Okay, so show me how gravity was involved in that.
You want me to tell you why gravity is involved?
Yeah, because you just claimed that gravity was involved, even though I just did an experiment manipulating only the medium. That was the only thing that changed was the medium.
Sorry, what was that? Clark.
So
Okay, and-
can you show me how gravity was involved?
Yeah,
And
absolutely.
which gravity are you talking about?
Our gravity, I guess, globe Earth. So.
No,
if
you
we're
got to be specific. What do you mean our gravity?
globe Earth model gravity, scientist gravity.
What is global Earth? What is that?
Yeah, what is that?
Mass.
The hell is that?
Okay, are you going back to mass attracting mass, even though it was debunked by the professor of physics
Gale.
of Yale?
Didn't you just ask me to explain why gravity was involved?
Yeah.
Yeah, and you went
What
back
is-
to a gravity that's already been debunked for 106 years.
Those two
Which was
rocks.
kinda weird, bro.
Those two rocks colliding, man. Hank, you can't. Man, I can't get those out of my head. Jeez.
Okay. Look,
Now you will explain why Einstein was wrong.
Yeah,
You
you
want
should
me to say
ask
why-
Google if gravity is a force. Is gravity
No,
a force?
he
Hey Google,
he
is
needs to
gravity a force?
explain. Yeah, he does. He needs to Google that. He needs to explain why he just went back to a gravity that's been debunked for 106 years. After we just showed him, because I'm an egghead on the internet, right? What the hell do I know? But the chair professor of physics at Yale, do you think maybe he knows what he's talking about a little more than you?
Yeah, absolutely. Of course, he knows more than me.
So why did you just go back to your vomit like a dog, right? That's been thoroughly debunked. Nobody's claiming gravity is a force and mass attracts mass anymore,
Okay.
except you.
Okay. Here's what Einstein's model says. It says that mass creates a disturbance in space-time, and this disturbance directly causes other masses around it to go towards the first mass, I guess. And that's what we see as mass attracting mass, which is why they both kind of
No,
work. Einstein
no,
is
they both don't kind of work.
okay. Why is
Okay,
Einstein
so
wrong?
do you not understand that Einstein superseded Newton?
Okay, great. Smile. Listen, Hank, because he said this is, and then mass attracts mass is connected. Smile. Can you post it now? Anyone who wrote anything about what you said now?
About mass attracting mass?
That connected with the bending through space time.
Oh, sure. Give me a minute.
Okay.
Hey, did you know that at least Einstein's theory is demonstratable?
Einstein's theory of what? He has
Special theory of relativity. At least it's demonstratable.
yeah,
This
most
substitute this
theories
fabric of space-time with spandex, and substitute planets and stars with masses of clay
Oh.
balls.
You're making fun of it. Okay.
No, this isn't making fun of it. This is an actual demonstration. When you look up how Einstein's theory of gravity works, YouTube videos, they all have this kind of demonstration of it.
Stupid demonstration meant for people who don't really understand it, who kind of want to understand.
I think you don't understand what gravity is, though. I don't understand you realize the gravity of the situation.
Okay, so here's a good website. I mean, it's not really that credible. If you want me to find something better, I can find it, but it has a good explanation.
We're
So-
not going to dismiss your website. That's a genetic fallacy. Give us your information. We'll look at every information that you provide and we'll critique it based on its merit rather than where it came from.
How about one famous scientist who realized that is connected? It will be very great.
That what is connected?
That what you said before, that everything what was connected with, you said that it's connected, mass attracts mass because of bending of space-time.
Yeah, I can find that also.
Okay,
Do you
come.
want me to just read it out, or do you want me to post it so you
No,
can?
no, I wanted it. Yeah, scientists experiment everything, you know, all work, publication, whatever. Because on the end, it will be only your story, nothing else.
I haven't. Wait, is that New Zealand? Well, I haven't seen New Zealand in so long. Okay. So yeah, you're all. The thing is, you guys fundamentally kind of misunderstand what scientists say.
Listen, man.
Wait a
Fundamentally.
minute. We don't care. Hold on. We don't care what scientists say. Go ahead, Justin.
No, Hank, take over. I just that word.
Yeah,
Yeah,
you're good, bro. Okay, hold on. Scientists,
That
we don't care what scientists say, right? We care about the empirical results. This isn't the scientist's favorite color class, right? This isn't home economics. When you're in the server, we're talking about what is verifiable, what is empirical, most importantly, falsifiable, and that which is true, right? If you get a result from an experiment, you can disagree with it all you like. And the scientists can say, well, light is a particle and it's a wave. But that doesn't have anything to do with the experiment. The results is that the knower of the witch path information collapses the wave function. That's the result of the test. We don't care what the scientist says afterwards. It's hot air. We only care about the scientific method because of its ability to eliminate other causes and to demonstrate that there's one cause to this effect, and its cause and effect relationship has been established. That's all we care about here. So please tell me, what is Michio Kaku's favorite color?
I don't care.
Right? Right. He doesn't care either, right? Because he says that no one he knows in his field uses the so-called scientific method. He said what he does is guesswork, leaps of logic. I'm going to post it right now.
Isn't that the scientific method? Coming up with a hypothesis?
No.
Uneducated
Guesswork,
information?
Smile, can you be honest
leaps
now?
of logic.
Can you be
Look,
honest
it's
now?
not
And
you
tell-
versus me, right?
Smile, can you be honest now in this moment and tell me this?
Okay.
I don't know who is doing this.
It's
Can you only
CCR.
tell me this? Can you tell me, did you made it up that what you say when you started because you wanted to connect it,
make
to
more
something, but you didn't?
observations, and it's a very science. We always say that you make observations, you have a theory, you go make more observations, and it's a very, very tedious process. Wrong. Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork. It's guesswork. It's guesswork.
I'm gonna move a pencil for you. With just psychic powers. James, show us. You are now prepared to waive the demonstration with the pencil.
Yes, and the reason is rather simple, because the pencil reacts to even the currents of the air conditioning in this studio. It will be very difficult to try to put controls on it in such a way that normal currents of air that are present all the time would not move the pencil. For example, it moves very, very easily.
Kind of prediction that forecasts how the independent variable will affect the dependent variable. So the independent variable is the cause, the dependent variable is the effect. So hypothesis. The hypothesis should also contain a prediction about its verifiability. For example, if the hypothesis is true, then 1 should happen when 2 is manipulated. The first blank is 1 is the dependent variable. It depends on what you're doing the second blank, and the second blank 2 is the independent variable. You manipulate it to get a reaction. There should be no other variables in the experiment that may affect the dependent variable. So, The scientist applies his or her present knowledge to predict the effect on the independent variable on the dependent variable. The prediction is a statement of the expected results of the experiment based on the hypothesis. Right? So if / then statement. If I manipulate this, then this will happen. If I turn on this switch, then this light will come on. Does that make sense?
That makes perfect
So
sense. I already understood
if
that.
I take the water out of this fish tank, the apple will fall. What did I prove?
You proved that specific gravity or relative density is correlated to whether an object falls towards the earth.
Right. So you said that there's some other gravity involved. I need to see where that's at, because the scientific method distinguishes science from all other forms of explanation because it's requirement of systematic experimentation. Right? And I'm about to post that. So I need you to get, your notes and get prepared to post it in the live stream where everybody can see it, because I'm posting stuff that's, pretty relevant. All right, so the next thing says, the final arbiter of truth in science is experiment. Not what the scientists say, not what comes out of their mouth, but experiment. The only way we change our mind in physics, let me restart. The only way things change in physics is experiment. Everything is based on experiment. That is the only way we change our mind. If it doesn't agree with experiment, it's wrong. In a simple statement that it's key to science. Mathematics is not a science from our point of view, when in a sense it's not a natural science. The test of its validity is not experiment. Experiment is the only means of knowledge at our disposal. Everything else is poetry, imagination. So you say we don't understand what scientists are saying. We don't give a fuck what scientists are saying. We only care about the results from the experiment, sir.
Scientists have to say the results, right? That's what I'm talking about.
No, they pass the hypothesis, the experiment to someone else, and then they do it themselves. I don't care what the guy says. I just want to know what he did and what he expects the results to be.
Okay, here's the thing that the other guy asked me to do, which is prove that Einstein is still right. Okay, look, if you want me to talk around Newton's laws, because it's annoying to do that, because
Yeah,
Einstein.
let's go back to the Earth, please.
Okay.
Let's go back. Let's find curvature, please.
Okay.
Because I want to be Glover. If you show me curvature, I will be immediately now.
The thing is, I could show you all the pictures, but of course those pictures.
Can I show you something? Can I show you one picture, please?
Sure. Go ahead.
Okay.
It's probably gonna be like you're able to see a city from a long way away or something.
No, it's not city. It's called horizon. That's what is curve in your globe model. You know? Okay, it's there. You can read. Can you read loud, please? Because my English is not so.
Your English is fine.
Yeah, it's all right, but maybe accent and maybe I can read if you don't want.
No, I'm reading it. I already read it.
And
Okay, there we go. That's very interesting, but there's a lot of different explanations for that.
okay, can
We
you
don't care
explain?
about explanations. Any village idiot can give an explanation of what they think that they're seeing and why it's happening.
Oh, when there's a reasonable reason to think that what you're seeing might not be the entire truth, then you should probably use it, shouldn't you?
Yeah, but why we see 10 times more than we should to see?
So are we debunking the Earth right now?
I'm asking you why we see 10 miles and we need to see 1.22 miles.
There's some very interesting. There's some very interesting laws that determine light in the atmosphere because of density. It's weird, but yeah,
Uh-huh.
density curves in such a way that it
Okay.
somewhat extends how far you're able to see.
Okay. Can you now post me one sentence where it's written like this? Because of density, because of whatever you want, horizon extending.
Sure.
Okay. Post me. Did you hear me?
Yeah,
That
yeah.
they will not misunderstand each other. You need to say that some kind of phenomena doing something, and after that saying extending horizon because of that phenomena.
I'm not sure I'm gonna get that exact wording, but
But
fine.
that's happening in nature. You know, that's this picture. Let's now find out which phenomena is doing this.
Yeah, I just want to say that Michio Kaku and all these theoretical astrophysics physicists and cosmologists, I just want to say, according to what we just said, or no, well, not what we just said, the sites we cited our sources. Basically, all these scientists they're not really scientists; they're poets, and they didn't know it.
But like they're not telling the truth, or
They're not using the scientific method. Everything else is poetry. Did you hear the thing that I just said? I cited my source. I read it out loud.
yeah.
I was
So
hoping you were listening.
I was
So if it's
absolutely
not coming out of the scientific method, everything else is poetry. So Michio Kaku said no one that he knows of in his field uses the so-called scientific method. So all these people who thought that they were scientists, they're actually poets, and they didn't know it.
wait. Can I get that quote because I don't think you posted that one.
I did.
Okay, I'll go back and look at it.
Almost all the way down, it says poetry. Everything else is poetry.
Oh no, not that one. The one about Michio Kaku saying nobody in his field.
Drace posted that. That's Michio Kaku. Scroll up a little bit. Like not even 10 minutes.
Uh, oh, I see it.
So is Ladies Night through with for this week or what? Because I'm still streaming. It must be good. Good time with dinner if Jenny's not back.
Okay, I see the clip. Sorry, was somebody else talking?
It's okay. We were talking about ladies' night. So what did he say in that clip?
He said exactly what you said. He said in his field, scientists do not follow the scientific method. They go by the seat of their pants, and they use guesswork.
Right. So logical leaps, we call those fallacies. When someone makes a leap of logic, we usually say, "Hey, that's a logical fallacy." Right? So what does it say at the bottom? Experiment is the only means at our disposal. Everything else is poetry. Max Planck, Nobel Prize, physics. So when I said that all these people that thought they were scientists, they were poets and they didn't know it. Isn't that what I said?
Yes, that is what you said.
Right. Does it make sense?
Somewhat.
According
But I
to
think
Max Planck, if they're not using hypothesis test, which the only way that you can have a hypothesis test or an experiment is if you're doing natural science. So all these people, you said that we don't understand what the scientists say. I don't have to understand their poetry. I only have to understand what comes out of experiment.
sure. Okay. Again, I posted.
Which is the results.
Right. I posted the experiment that proves that Einstein is right. For whoever wanted
Okay,
that.
what's the natural observed phenomenon?
something pretty complicated.
What's that?
By comparing NIST/ILL measurements of energy emitted by silicon and sulfur atoms, E is different from mc squared by 0.4 of 1 part in a million. And it's very, very
Okay, so what does that mean? If you understand something, you should be able to explain it so that a 6-year-old can understand. So what does that mean?
I don't think you're gonna be able to explain this to a 6-year-old, but the amount of energy that mass contains was inconsistent with Einstein's prediction of E equals mc squared by a very tiny amount, but 0.4 of 1 part in a million. So that's like what, 1 in 250 billion.
It sounds like you said Einstein was wrong. How does that back up what he said as being true?
Well, I was reading the first part of the article, but then it goes on to say, what was it going to say? Okay, so it says that the experiment was full of noise, and it goes on to tell you that there's a new technique involving 2 silicon and sulfur ions that eliminate like most of the noise that exists. Or, well, by noise I mean what would you call it? Like sensor. I'm forgetting the word. Sensor uncertainty. That's. I can talk
Can you
louder.
elaborate? Yeah, it's not the loudness. I don't understand what you're talking about. Like everything I've said so far, I'm pretty sure everybody can understand. I don't understand what you're talking about, and it may be my fault, right?
I don't think it is. I'm pretty bad at explaining, but anyway, so the experiment is this. So they're measuring the energy emitted by mass, like total mass. This is defined by Einstein's equation E equals mc squared. And the experiment that did it first, or not first, but one of the experiments did it so that it was slightly off of Einstein's prediction, but the problem was that there was a little bit of noise and sensor uncertainty. So a new test proved that it was incredibly accurate, even more accurate than the other one because it eliminated the noise that was present, and it was way more accurate. So well, it's just proving Einstein right on his one equation. On
What
only that.
noise?
Noise, not noise like sound, noise like uncertainty. So
Like junk data, anomalies?
yeah, like that.
Interesting how that works with equations, huh?
What do you mean?
Do you think those anomalies would happen in reality? Or do you think those anomalies would only happen in trying to explain something with an equation rather than a measurement?
Well, I already told you there was a more accurate experiment done later, and it was, well, the noise was gone because it was
What
more accurate.
experiment?
Comparing the amount of energy emitted by a mass particle.
No, but what's the name of the experiment? Do you know? Do you know who ran it? What university funded it?
Yes, it was funded by the National Science Foundation and NIST.
NIST, huh?
Yeah. What, are they not like a reliable thing for flat earthers?
Well, it's government, man. It's just NIST.
How about to provide that phenomena which extends horizon? I would be so appreciate if you can, that I can read more and be educated more about that.
Yeah, I actually forgot about that. I'm looking it up.
Oh,
It was a little bit of time ago, but I'm trying to look for the thing in my history.
but it's easy, you know. You go there, which phenomena extends horizon on Google, and then you'll be for sure millions proofs, whatever, and it will came the name, everything for sure.
No, you're right, but there was a really, really good website that explained it
Well,
perfectly.
let's find one site, whatever, saying that one phenomena. We will say which phenomena, extending horizon.
I found it, the one that I wanted.
Okay.
Okay. I'm so happy. I love this website. It was
Can you
so.
post it?
Yep, there it is.
Oh. People often ask how far you can see or how far it's to apparent horizon. This question is okay. Where is written that horizon extending?
So you see the top of it, and then you go like scroll downwards, and it'll say refraction considered simply.
Yeah. Okay. Now read that. What is the main point? Read that we can hear.
Okay, usually air is densest at the surface, so rays of light are concave towards the surface. They bend towards the surface. But
No, man. Can you read that? What is the main point of this? What I ask for you. I will. But read what is main point of view. I asked where is written that extending horizon. Now you are saying something, explaining to me. No, can you read the main point? I don't want to go into all of this. Can you read to me where is that I can see?
you want to just have a statement that says that horizon is different than normal?
It's extending. It's not where should to be.
Okay.
Do you want to speak of refraction, maybe?
That is what's causing you to be able to see farther.
That's what causing. Do you know that we have 5 types of refraction?
You have what?
We have 5 types of refraction. They explain it all that refraction, what's happening. You know, all these things. What you put it now, they explain it in 5 types.
Okay, what are the 5 types?
I think it's. I don't know. Maybe I will. Maybe I know 4. It's mirroring. It's syncing. It's miraging.
I put it in the text chat. It's in the text chat.
Looming.
Yeah, I'll tell you. It's sinking, looming, stooping, towering, and mirages. Those are the 5 types. There are many types of mirages, but those are the 5 types of refractions.
Okay, now you need to now you need to look in that 5 types of refraction to educate yourself and to find out in which of these 5 horizon is extending. And I will tell you in no one of that, because in no one it's also saying anything about horizon itself, only about something happening reference to the horizon, not horizon itself, objects on horizon. You understand? All these 5 refractions, and listen, these 5 refractions, they are distortions. You don't have distortions to see more. You have distortions to see less.
I'm gonna have to disagree on that.
Okay, now great. Now post that what I asked you. Which kind of refraction extend horizon?
So
And
we were talking about different kinds of refraction, right? Are we talking about different kinds of mirages, or different kinds of refractions, or different?
we are speaking about terrestrial refraction.
Yeah, I heard a lot.
Then you need to have radius in the first place for that refraction.
Yeah, there's
literally. But
literally.
where is the radius in the first place? You cannot have refraction and say there is the curvature. You need to have curvature, and then of course you have refraction.
Yeah, the website I gave has like. Actually, wait. I can send the calculator that's there too.
Man, I'm asking you a simple question. Which type of refraction extending horizon?
Oh,
Refraction's kind of a blanket term, right?
yeah,
It's like saying white people. Like, what do you mean? Like Canadians, Australians, Irish, English? So you got to be hyper specific.
yeah. When about stuff like mirroring, you're literally just talking about light bouncing off a mirror. Like refraction, like the term, I guess, is just talking about light changing.
Do you know what are you saying now?
I
Do
hope
you
so.
know what? Do you know this? I know this. Like I know this thing so well that I will explain these people because I'm so sure 100%. Because I know this 100%. I know everything about refraction. I don't know that there is 5 types of refraction, but I know everything about refraction. Now I will explain.
Please do.
Man, you are trying to explain something and you don't know even that things has 5 types. I know that. I cannot speak about more. If somebody asks me what is thinking, I don't know. But it's not extending horizon that I know.
No, no. See, refraction's just talking about light changing direction. It's not talking about refraction due to density.
Can you see around the curvature of the Earth? Is that what it's talking about?
Somewhat. It's not.
Okay, so if you can see around a corner, that's the same thing as seeing around the horizon, correct?
No.
Yes, it is. That's exactly what it's saying. So if we can see around a corner, I should be able to just look out my door and it looks to the left automatically.
But that's like the biggest misunderstanding because there's no.
I know, right?
Hold
But
on.
yet we see more horizon past the distances that we're supposed to see the horizon at if we were on a structured globe model.
I know, but hold on. Looking around the corner is not the same as
So
being
when you bring in refraction, you're not bringing in the globe Earth model.
But okay. I'm gonna look. Looking around the corner.
You're
is not-
extending the globe Earth model, man. You're literally extending the globe Earth model with refraction. That's what you're doing.
Smile. Do you know that in your model, horizon must, listen D, must be geometrical?
Yeah.
Think about it like this, bro. There's a woman, she's 9 months pregnant with triplets, and she lays down on the doctor's bed flat on her back. And the doctor says, "What color are your toenails?" She don't even look up because she knows that she can't see her toes. Why
Okay.
can't she see her toes?
Because her fat belly's in the way.
Yeah, like a big curve, right? Like a big earth curve. When you say that's very similar, because if the earth is a ball, right, there's going to be curvature, and it's going to keep you from seeing things. And if the horizon is only 1.225 miles away at 1 foot observer height, and you see stuff that's way past it with the horizon behind it, what does that mean?
Well, I
That the
think
radius has been debunked.
most people aren't 1 foot observer height. First of all. Second of all.
Yeah, I know. We put cameras down at 1 feet, and we can see further than we're supposed to see.
Maybe, I don't know. I haven't seen it.
No, it's not maybe. You can go do this.
It's not a maybe. We all in
Look-
here have done it.
Look a
we
little bit
can't
the voice,
if we're not a
voice text chat. People are posting everything. Look a little bit.
Yeah,
Okay,
did you
so
do the
the
Black
oth-
Swan with him?
No, they didn't. Because I have no idea what that means.
Okay. Do you wanna have a look at this one? Do you see where Justin's posted those oil rigs?
Oh my God!
Oh, no, they have. Never mind.
Oh, you've seen it. So
Yeah,
so then you know that the horizon's further observably than it should be according to the globe model.
Well, no, according to the globe model, refraction plays a giant role in it.
No,
As soon
because
as
in the
you
globe
use the
model,
refraction, as
no,
soon
no,
as
no,
you use
look,
a
look,
refraction, you're
sorry.
not
look,
using a
look, look,
physical object.
look. I'm posting the image of it, right? This is what the globe model says your horizon is, right? That's what they say
Yeah.
boats go over.
Yeah,
But
of course.
that can't be the case if we're seeing the horizon beyond those oil rigs, right? Because the globe model is saying that that point is well in front of the oil rigs, and we're seeing it behind them.
Right, but I'm saying that because
Yeah,
the
you're saying
light.
that the horizon isn't geometric, right?
No, of course that's not what I'm saying. I'm saying
No, you
that
are though, because you're saying it's refracted. That's not geometric, that's optical. Even if it were the case, which you don't know, that's just like a post hoc theory that you've heard that you're now repeating. But you're saying that it's not a geometric horizon.
Yeah,
Because a
he's saying that.
geometric horizon is 1.2 miles for a 1 foot observer. That's what the model says. So if you don't agree with that, then you don't agree with the globe model, which
so
is
wait.
fine. But
So
that's
you're
what
saying
we're
that
comparing here.
Sorry, you're saying the geometric horizon is one defined entirely by geometry?
Well, you're supposed to have a geometric point on a ball that you can no longer see beyond, that boats and things are going over, correct?
Yeah, where's your edge, bro?
That's
Shouldn't there
what.
be an edge where you can't see past because there's curvature?
Yeah, they've said
You live on
that's
a globe Earth, right?
that's been the proof since Aristotle, so they say. He went out and saw a boat, and it disappeared bottom up, meaning you live on a ball, right? That's
Yeah,
always been the proof.
well, the globe model don't believe in you, so
In what?
I'm just
In
joshing.
Yeah.
okay.
So the globe model makes that claim, right? We see boats disappearing bottom up because it's a curve of Earth, because you live on a ball, right?
Yeah, it's one of the examples that you can
Yeah,
use.
but that image is showing you that that's not the case, because it's 10 times further than that geometric horizon is predicted to be based on the size of ball that they tell us it is, right? So the observable Earth is disagreeing with that story.
Okay, well,
Smiley, can you just put the volume of your mic up a little bit? Just a little more up, please. Thank you.
yeah, sure.
Thank you.
Give me a second. I need to figure out how to do that.
You can manually turn people up as well, but you've maybe got them at 100. Vlad, I don't know.
I know how to
Go
do
to
that.
settings and then voice and video and then output, I think, or input.
So also, beyond that, Smile, so beyond seeing the horizon way further than it should be, to a point that totally debunks the radius that we're told, the only reason that you would have to assume that it's some refraction of light occurring that's just flattening out a ball, you're already making the fallacious assumption of a ball, because that bit hasn't yet been proven. This is supposed to be the thing that proves it, this geometric horizon, right? Beyond that, you're just assuming that it is a ball, despite having zero observable element of a curved ball and zero measurable element. No one's measuring the curve, but you're still kind of defaulting to, well, it must be light bending around a curve. There isn't a curve. You haven't established a curve. We observe no curve. That's what this was supposed to prove, but it doesn't, because the horizon isn't geometric. It's optical. Do you see?
You're right, but I don't think we're talking about the globe Earth proof of ships. I think we're talking about the flat Earth debunk of Earth through the thing.
No, because the geometric horizon is what they say is causing boats to disappear bottom up. That's a thing that Bill Nye and Neil deGrasse Tyson and all that still say. They still say it today. You know you live on a ball, guys. I know it looks really flat and motionless, but when you go out to the beach and you look at a ship and it starts to disappear bottom up, you know you live on a ball. That's still
Right.
what they're saying. And you know that's not true, right?
But they ignore perspective and the Rayleigh criteria.
Yeah, we can show you things disappearing bottom up on a flat surface. So there's no
Can
need to
you?
assume a curvature. Yeah, you in the live stream voice text?
Yeah, I am.
Yeah, so look, I'll post a couple. Right, so you can do this yourself. Get like a long table, take an object like a coin, have a friend pull it away from you while your eyes down to the table, and you'll
But
start to
the
see it
camera
disappearing bottom up. Oh
the
yeah, but the
camera is
camera's
below.
below the table, right? Okay, so watch this next one. This is the same setup, the same table, the same camera. He's just placed the coin to the end of the table. Now he's about to zoom in, and what do we see? The coin at the end of the table. If it was underneath that table, he wouldn't be able to resolve that coin at the end. But it's an angular resolution thing. It's not a physical obstruction of the table. So we can demonstrate this exact effect of a disappearing bottom up over flat surfaces which no one is claiming is curved. So again, it's fallacious to jump to they must be disappearing bottom up because of curve. Do you understand that?
You're right. So, okay. So what happens if we zoom in on a ship that's disappeared? You won't be able to
We
see.
bring it. Yeah, no, we bring it back into view. Look at this. Yeah, see, they've been posted
That's a
in the
problem
chat.
with angular, like we were talking about angular.
Right, it's a
resolution.
perspective issue. It is not a curvature of the surface issue. That's the whole point. They've
Right, but this
hijacked
boat,
this and said it's because of a curved surface. But we can zoom into it. So obviously the boats have not gone behind any physical curvature.
No, you're right. These specific boats haven't. But
well, so you can't claim that any is. When you see one, you can't claim it is, because how would you know it's not just this effect, which we can demonstrate?
Because
we cannot demonstrate a curve.
Okay, so you can. Okay, so there's a boat, right? It goes
Wait,
out.
2 seconds, just 2 seconds. Jenny, I was asking where Ladies' Night was, and whenever you want to resume it, just jump in. If there's ladies that want to take over, go for it.
Oh, hey, you know what? It's all good. I was just kind of doing a check. I was, if
I was
there wasn't
confused
any.
too.
Yeah.
Where are the
Oh, well,
ladies at?
I don't know. I just got off work.
Okay. Well, you hunt down the ladies, Jenny, and we'll get it kicked off again.
KJ is here too.
After 1 hour, there was
Yeah,
nobody
KJ.
around, so it ended kind of after an hour.
Yeah, one of them had to go eat, and then.
Oh, that's a shame.
Well,
Well,
I mean,
there'll be more
I just
joining,
wanna-
hopefully.
I just want to point out that if you look at the gift that I posted with the sun, right, and you see during the later part of the gift, as he's pulling it away, right, it appears to sink or set. Some people would say set. If he were to continue to pull it away, wouldn't it disappear from the bottom up?
No, it would still be visible. That's the
Watch
problem
it
with.
again. Watch it again. When he puts the slide in front and he shows you the picture of the water, it's going down. If he were to keep doing that, if the gift didn't end there, and he were to keep moving it, wouldn't the sun disappear from the bottom up?
No, and I can explain this to you. This is geometry, right? So let's say that the sun is at a height of 1 meter, right? You push it out 1 meter, right? So now there's a 1 meter by 1 meter like triangle that's formed, right? That's a 45, 45, 90 triangle. So the angle that you can see it at is 45 degrees. You push it a lot farther back, like let's say you push it 100 meters back, and suddenly it'll look a lot lower, and the angle will, well, you'll have to do trigonometry for that. But as you keep pushing it, as you push it out towards infinity, the angle that you see it at gets smaller and smaller towards zero, but it never goes below zero. And at a certain point, you won't be able to see it anymore because your eyes can't do that. But
yeah, when it
that's
reaches the angular resolution limit of the optic, it's going to start compressing, and it'll compress from the point of the horizon, and it'll disappear bottom up optically. This is what's occurring. But the other side, your side, I'm not saying it's your side, but you know what I mean. They'll say, but it has to be the curvature of the surface. But then we'll say, what curvature of the surface? You observe no curvature of the surface. Show us who's measured curvature of the surface. No one has. Okay, so why are you claiming this is curvature?
Okay,
Do you
well,
understand?
I would say it doesn't actually disappear bottom up.
I mean, they don't always. It's an optical effect, so it changes with conditions. Sometimes they don't. Sometimes they do. It doesn't.
So
The
wait a
point
minute.
is, it's not from curvature.
Exactly.
Wait-
No,
Wait
I
a
mean,
minute. Is Smile of Death claiming that the sun doesn't set?
no,
Look a
no,
little
no.
model.
I'm claiming
No,
that.
he claimed trigonometry because he said that. He kind of hand wave dismissed what I said with the magical word
Yeah, I
trigonometry.
noticed that. I noticed that.
But I just
All
wanted
right.
to make sure that Smile gets that, you know, there's a fundamental assumption being made here that needs to be evidenced, and who is evidencing it? You know, I mean, we observe a flat horizon, a flat surface. Someone's claiming it's actually curved. Okay, what's the evidence proof for that? And it's not coming forward. But you would need that to then start assuming, well, the reason we see the black swan is because the light is bending around the curve that I'm assuming, and everything else. Right? You can't just base everything on an assumption that you haven't proved. We're getting to Sillyville.
Sorry, guys. I was away for a minute. All right.
Foundational assumption, the curvature. What's the best evidence for it?
Best evidence, I would still say, is ships. I know you're going to argue against that.
But you've just seen that the horizon is geometric, so how could you say ships are going over a curve when you don't observe that?
Well, because the entire argument for why you can't see them anymore is because of angular resolution. But
No,
if you
your
zoom back,
argument is that it's curvature, but you have no curvature. Where's that ever been measured or detected in all of human history?
well, no. I'm saying that ships are disappearing bottom up. That's a fact, right?
Because of why? Why are they
No,
disappearing bottom
that
up,
is
though?
not a fact.
They don't always disappear bottom up. It's an optical effect. But why do you think some boats sometimes disappear bottom up?
That means that if you take a boat on that oil rigs, they will disappear 1.2 miles. Are you saying that?
Yeah.
Think
Okay.
about this. Think about this for a second. What happens when the light from, as you imagine it, light is bending down, but now it's on a flat plane? What happens when the light rays from the bottom of the boat on the way to your eye are bent down and hit the ground? Do you see the bottom of the boat?
No,
What
if
do you
they've
mean?
been down and hit the water, they never reach your eye.
Yeah. Yeah, that's like
So then you won't resolve the bottom of the boat. And it has nothing to do
exactly.
with curvature. Yeah, it has nothing to do with curvature. This is the point, right? I need to clarify with you your claim of the boats disappearing bottom up. You're claiming that's because the surface of the water is physically curving down. Is that correct?
Yes.
Okay, what is your evidence for that claim?
Okay, so you have to be really specific here. So the observation is that the boat curves, or the boat disappears bottom up. First, we have to prove
Yeah.
the observation, right?
Okay, we can agree that we sometimes observe boats to disappear bottom up on a flat horizon. That's what we observe. Okay, next step, how do we prove that that's actually going over a curve?
Well, you asked me for the best evidence, like the best easy evidence that we're on a curve, and so that's what I'm saying.
No, but the observation isn't that the surface is curved, it's that we observe a boat to optically disappear bottom up on an observably flat surface. That doesn't prove curvature. That's an
No,
assumption that you
it
have.
doesn't prove curvature,
So
but it's one of the
I'm
biggest
asking,
pieces.
what does prove curvature for you to make that assumption about the observation of the boat?
It's more. There's no one piece of like evidence.
Well,
Like,
there has to
hey,
be some evidence because it's what your whole worldview is based on, and it contradicts the observable nature of water that we all know, which is that the surface is always level. Because I mean, the surface appears to be level, but you're saying it's actually curved. That's what explains that disappearing bottom up. But when we're saying, okay, but how do you know it's actually curved? You've said, well, it's not just one thing. Okay, give us the best thing. Has anyone measured it? It's physical. So has anyone ever measured that?
I mean, I don't know. So I accept evidence from NASA, right? I believe NASA.
So appeal to authority, that's a logical fallacy. We don't do that.
And before
You're-
NASA, what was before NASA? How NASA realized that
But do you think NASA claimed to have measured the curvature?
somebody's measured the curvature. I don't know if it was NASA or
Yes,
not.
somebody must have measured it, right?
Mm-hmm.
Let's find
Okay,
who.
so who was that? I mean, Google it if you want.
There were a lot of people, Aristotelians. So if we're okay, well,
No.
on
That's
the
not a
assumption,
measurement of curvature. That's not a measurement. That's an assumption. He looked at shadows. He did not measure a stretch of land or water and say, "Look, here's a curvature of that surface." He didn't do that. He assumed that. Who has measured it?
He lived 300 years before Christ.
What?
He lived 300 years before Christ.
Okay.
We know who it is.
So you
But
must have
we
someone a
want-
bit more contemporary, right? I mean, at least this century, would you think?
See, so I was having this discussion also. It's not possible. Okay, I'm already
So
gonna.
no one's measured it.
No one's measured it directly.
And so no one's measured it and no one's observed it. Okay, so I will ask again, what is the evidence for this curvature?
Sorry, somebody lagged out.
Yeah, someone's roboting. Hank, you're roboting. Or that's just me. I don't know.
No, it's him. I can hear it too.
Okay, so no one's observed it, no one's measured it.
That's Hank.
How do we know it's there?
Well, people have observed it, but you don't
Well,
believe
no
their
one.
evidence,
You
right?
can't. No, you can't verify it. You can't observe it, and you can't measure it. Correct?
I can't. No, I can't.
Yeah. So we have to appeal to authority, which is a logical fallacy, to make that argument. So, there's
You're
nothing we can do to verify that the surface we live on is curved. Is that correct?
you're right that. Okay, you're right that appeal to authority is a logical fallacy, but
But in this case, I'll use it for my entire worldview. Come on, dude.
no, that's not what I'm arguing. I'm arguing that in some cases it's okay to take the opinion of experts.
No, because that's
Simply,
exactly what the fallacy is.
no. Appeal to authority is appealing to authority. That's appealing to the government. That's
No,
appealing
no.
to.
It's appealing to even someone who claims to be an authority on a subject or an expert in a subject, and you don't have anything beyond their claim that it is this. So if you claim that they have the authority to know that, okay, show us their measurement that gave them the authority to say, we're an expert in this. This is what the curvature is. What is their measurement? Show us that.
What
The
is their
people that you
measurement?
believe. Yeah, so you say, okay, I believe NASA, for example. Okay, what
Right.
is their measurement?
Of the Earth's
The-
curvature.
Of curvature, yeah, that we live on a ball.
Okay, it's like well, it's what's the circumference, right?
Curvature. How did they measure it?
How do they measure it? Well,
Yeah, well, you said this is the guy I believe that has curvature on lock. He knows it. He's the authority. Okay, what's his authority based on? What measurement is he citing
right.
to
So
show you that he's an expert?
NASA
If that's
has
the
made.
appeal.
I know. NASA has made the assumption that the Earth is flat based
Oh,
on
assumption.
a series. I know series of evidence such as the ones that we already talked about, plus their satellites, plus
You
a
said the Earth
lot
is
of.
flat, by the way. I don't know if that was a Freudian slip or what, but
Did I actually?
yeah, you said the assumption that the Earth is flat. I think I'm pretty sure that's what you said.
Oh, okay. Well, that's not what I meant. But
I know you're right. Okay, so so it's an assumption. So they make the assumption. So the authority that you're appealing to is telling you it's an assumption. So okay, we get to that point and we say, okay, well, an assumption isn't exactly what we're looking for here. Could we find some
no. They have to
empirical
make
evidence?
they have to make the measurement on the assumption.
What
They might
measurement?
already know it for a fact, but they still
No,
have to
but
make
you
the
can't.
measure.
You can't know it if it's never been measured or verified.
That's not true.
Well, how can you
How-
know
Okay,
what
imagine.
the curvature is if
Wait
you
a
can't
minute.
measure it?
If you said that you can't measure it, right? Insinuating that it can't be measured because it's too big, then how do
Mhm.
you even know it's a ball?
Well, no,
Thank you.
Who? Hello?
I just said thank you. That's a great point, Hank.
Okay, so I said it cannot be directly measured. Or that's what I meant if I didn't say that.
No, but
It
the other
cannot be
things,
directly measured.
if you're saying that Eratosthenes is an indirect measurement, it's not even that. It's a pure assumption. He doesn't even attempt to measure the surface. Who is attempting to measure the surface and finding a deviation due to curvature? If
Well,
it's no
you're right.
one,
You're right.
then
He
there is
measured
no
it based on the
evidence.
assumption. You're
Yeah,
right.
yeah,
He
yeah.
measured it based on the assumption that the Earth
Okay.
is round. But
that
knowing that the Earth is round is different than measuring it.
No, you don't measure it. You don't know it if you don't measure it. This is the whole point.
How you can know?
No, he
If you
doesn't. Yeah,
don't-
you can't know without no observation, no measurement, no knowledge, assumption,
can-
belief.
Okay, so say I take a picture of a ball, right? I know that the ball is round, but
Yeah,
I haven't
and you
measured
can
it yet.
measure the ball. Yeah, but you can measure it, can't you?
Well, yeah, but that's because I'm
Okay.
small. I'm big enough to measure it.
Right. Okay. So if no one can measure the Earth to be round or a ball, why do they keep telling us it's round and a ball?
Because they can make indirect measurements based on like pictures they've already taken.
No, because all of those things that you're thinking about required the measurement to begin with. You can't go into space without knowing the size of the ball that you're going to be flying around. That had to come first. So
Oh.
that's what they'll say.
Wait, so did NASA not go into space then?
Well, no, they didn't. But if they were to have, they would have had to have a measurement of the curvature to know the size of this ball that we're on, so that they can orbit around it. They couldn't have just guessed that.
You're right. I actually don't know.
Can you
Yeah,
show
this is
us?
the point.
You can show us like for example, if curvature is there, you will have, but on one distance you will have on 10 miles 66 foot drop. Then you will have, I don't know, on you will have that.
Yeah.
Yeah, do you know how much curvature they say is between over 10 miles, for example?
No, I don't know, but I'm sure I
How
could
much?
calculate it.
Just let's do this exercise. Just take a guess. How much do you think would be over 10 miles? Like centimeters, meters? What would you think?
Quite a bit, like kilometers, maybe.
Kilometers of curvature
Yeah.
over 10 miles.
Yeah. Why not?
Okay, so I guess you would think that would be pretty noticeable, wouldn't you? Kilometers of curvature over 10 miles.
Well, no, because if you do it over 1 mile, right, it's only a couple centimeters.
Well, 8 inches, so let's say around
Fine,
1
eight
mile.
inches, right?
But yeah, okay, so that is measurable then. So what they actually say is that it's 66.6 feet of geometric curvature over 10 miles, which is an interesting number, but without getting into that, that's what they say it is. So if
Yeah.
so if you were on one side of a lake and you had a friend on the other side of a lake, you're both standing on the shore,
Yeah.
and the guy's 10 miles away from you, and you're
Mhm.
looking across.
Hi, so I'm currently watching. I've been on this for 2 hours. I made a new live stream because they found my stream and started watching it, and I was hating on them on this chat with the others. And so yeah, so I joined the Flat Earth Discord, and I got verified, which means I can listen in to their live streams and everything. And so I did that. And I talked to them a bit, and I'm saying that I'm a skeptic, which I'm sure like I'm open to different opinions and stuff. So I'm listening to their arguments. I tried argumenting, but I'm shitty at arguments. They're like prove the atmosphere and prove all gravity and shit. And I was like, I don't know how to do that. Like, how the fuck do you want me to do that? So they're like, yeah, fuck off. Like they didn't say fuck off. They're really nice, and it's like good because you can have a debate with them. But like, yeah, that's the whole thing.
And you see that, it does cause the light to bend a little bit, and the straw deviates maybe like 10, maybe like 15 degrees. Well, that's the difference between the atmosphere and water. Now, there's a pretty big difference between the density of atmosphere and water, right? Because
Yeah.
there's no way in hell an apple will ever float in the atmosphere, but it can float in the water just fine. So the density is pretty big. It's a pretty big difference, right?
Yeah.
How much difference do you think is in between the difference of density of atmosphere and atmosphere?
You mean heated atmosphere and less heated
No,
atmosphere?
no. I'm talking about if the water is 70 degrees and the air above it 70 degrees, how much of a difference is there going to be between the density of the atmosphere and the atmosphere? Contradiction in terms, but the gas on the surface of the Earth.
Oh, well, the whole point is that the densities are different because the Earth is heated by the sun.
Bro, my point is that there's no difference in density between the atmosphere and the atmosphere. So what mechanism is causing that degree of angle for you to be able to see a deer on the other side of the hill and shoot it with a camera or a gun? What kind of mechanism is causing this thing that you're claiming that's happening? Because you haven't proved that the Earth is curving, but you think you say this word and it proves that the light is bending. The laser light is bending around a curve
Mm-hmm.
of 66 feet. Now, that's a building that's 6 stories high, and you think you can see a deer on the other side of it in the parking lot.
Well, yeah, so you brought up the fact that there's no change in density, right? But I say there is a change in density because okay, wait. So first we have to agree on one thing. Do you agree that heated gas has less density than cold gas?
Of course, it's called heat waves. Does that make the sun set and rise when the helicopter takes off? And there's heat waves behind the helicopter, and you see the sun do that wavy thing that it does? Does that cause the sun set and sunrise to happen?
No.
No. Does it cause deers to pop out behind hills and appear to float in the air like Superman jumping over buildings?
No.
So
Wait.
what mechanism is causing this great deal of refraction, because what you're claiming is that the Earth looks flat, but it's not. It's actually curved. Okay, how curved? At 8 inches per mile squared, right?
Mhm.
Or 66 feet at 10 miles. Okay, well, how come I can see that there? And you're saying refraction. Well, if that's true, then that means that the refraction is causing the curvature rate to be at 8 inches per mile squared, and it's also causing the light to bend down at the same curvature rate as the Earth. Lucky, right? Lucky, at the same curvature rate as the Earth. So you're saying that a laser light is bending down at 8 inches per mile squared, causing
Oh,
it to look
oh,
flat.
that's
What
not true at
mechanism?
all.
Yes, that is absolutely what would have to be. This is a true dichotomy. Either we wouldn't be able to see it at all, or the guy on the other side of the beach is visible, or he's not visible at 10 miles away. And if he's visible, then light is bending down at 8 inches per mile squared. What is the mechanism? Because we have never seen light bend down at 8 inches per mile
You're
squared. What is causing that?
Listen,
How do you prove that? How do you falsify that? Go ahead, I'm done.
dang.
Refraction is a magical word that these globers have come up with absolutely no proof for it, exactly like the globe. There's no proof at all that refraction is the answer to bending, to making things appear to match the curvature of the Earth every single time, no matter what distance. No matter what distance, it's automatically right there where it's supposed to be. Oh my God, that's refraction. What the fuck are you talking about?
Oh man, chill out.
Hey, you guys, can I just real quick?
Go for it, Jenna.
At one point in time, Karen B had a very extensive video about the black swan, but she investigated the buoys, but the concepts would still be the same. And I think she put it to private, but I found it on, I think it was Odyssey or something, somebody mirrored it, but it's called An Investigation into the Black Swan. I believe that's what it's called. Let me see if I can find it. And the reason why I brought it up is because of what Godrockin just mentioned and what Hank was talking about as well. You can't have continuous points of refraction just going around a ball. That's yeah. So let me see if I can find that for everybody. That's all I got. Thanks, guys. Go ahead.
Sorry, just
There would
let
have to
me.
be
Sorry, Hank. Just let me
Sorry, you
address.
go ahead,
Just let
bro.
me address it because at the end of the day, this is a red herring and a begging the question fallacy, right? So we're getting into non sequitur on the refraction side because when you brought up refraction last time, we dug into it because your refraction claim is based on a curvature claim, but you've already conceded that there is no evidence of the curvature in forms of observation or measurement that's verifiable. So you can't default to ignoring the geometry of the globe for your friend being hidden by geometric curvature at the other side of a 10-mile lake in favor of a refraction that you have no evidence of, no demonstration of, no citation of, in terms of extending a geometric horizon, that's assumed on top of an assumed curvature that we've already established we have no evidence of either. We only have the observation of flat. We have no measurement or observation of curved. We have no observation or detection of a refraction property that can do that to a geometric horizon, right? So to try and get into the refraction, it's like the gravity discussion. You're already assuming the things that you can't prove. This is the point. So it's fallacious to begin with, begging the question. The light isn't bending around a curve. You don't have any curve yet. That's still to be proved. So what the model would say is that no, you cannot see your friend at 10 miles away on the opposite side of the lake. He's supposed to be hidden. But in reality, as you know, you can see your friend, which is why you're defaulting to this story, this assumption about light curving around a ball, which is a load of assumptions that you have no evidence for, instead of just accepting what you observe, which is that everything seems flat and there is no obstruction to your line of sight over 10 miles, despite what the globe model says.
Yeah, let me give you three quotes real quick. This is
Not
from
more
Andrew
quotes.
Thomas Young, San Diego State University. It's 44 minutes after the hour. Major atmospheric refraction is guesstimated, or up to 34 arc minutes, and added to give accurate predictions. But just a minute, if terrestrial refraction is part of astronomical refraction, shouldn't we just be able to use survey's refraction coefficient to correct the astronomical refraction near the horizon as well? Indeed, shouldn't such a correction be required? And here's Andrews Thomas Young again. Some people have worried about how to apply the refraction law to such a horizontal ray of light because it does not cross any horizontal boundaries between denser and less dense air in a stratified atmosphere. In general, the curvature of the ray is different from the curvature of the Earth's surface, but here we are only concerned with the rays that bend just enough to follow the curve of the Earth. The simplest solution, horizontal ray paradox, is to remind ourselves that rays are an unrealistic mental construct in reality, and we always have a beam of light infinitely narrow. Rays don't really exist. So they don't have the conditions to actually cause light to go this way, but we guess it must be this way because we believe it's a ball.
No, I don't think that's right. He's talking about astronomical refraction, which I assume is
and terrestrial refraction. That's what we're talking about here.
Yep, I know.
Yeah.
Yeah, he's
And
talking
the
about.
problem is when light passes through a boundary, the angle of incidence it matters. So if the angle of incidence is 0, there's 0 refraction.
What? No.
It's
Yeah.
two separate mediums for terrestrial refraction. Can't just be air and air. Has to be like glass and something else. Then you can't just use air.
I think
and
it's
air. Doesn't work.
I think it's hilarious that you think you know better than Andrew Thomas Young, the expert in the field.
That's
right?
right.
I think it's hilarious that you're like, no, Andrew, you egghead.
But also,
Obviously.
on top of that, you understand that it's begging the question of you to assume bending light rays around a curve that we've already established there is no measurement or observation of, right, Smile? You get that? It's a begging the question fallacy.
Yeah, okay. Here's the thing.
Okay, good.
I've been wanting to say this for a long time, but there's a really big difference between giving evidence for the Earth, which is sometimes what you ask of me, and then other times trying to disprove the Earth and asking me to provide evidence that the model is correct, right? If I'm trying to prove that the model is correct, I can use whatever the model says. But if I'm trying to give evidence for the model, then I can't just do that, right? I can't
No,
use
but
refraction to
what
prove
it
the Earth.
is yeah, what the exercise is understanding what the model says for the globe, because that's what they tell us the Earth is,
Mhm.
and then finding ways to compare that to reality. Right? And the
You gotta
curvature
match
is a good one to do that. And we put them side by side, and we say, do these match? Is the horizon where the model says? Is the object over a distance where the model says? Is the obstruction where the model says? And what we're finding is that they don't match, right? So what do we do when we come to a situation where the reality we're comparing against the model doesn't match the model? Do we discard reality? Do we make up excuses for reality and stick stubbornly to a model that isn't predicting what it says it should be predicting?
Well, no, part of the globe model is refraction, isn't it? So
no, it's a geometric horizon. Old
okay,
school
look,
of it, remember? This is circular.
The globe
Bro,
model is.
You've already admitted refraction is begging the question fallacy. So why are you sticking to fallacy instead of logical thinking? It's emotional at that point, right? You're emotionally sticking to an idea, not logically. And what we do here is we try and stick, however difficult it might be, to logic, evidence, empiricism, and see where it leads us.
No, you're
and where
right.
it leads
But
you is that the Earth is not a ball.
you're right, but the entire globe Earth model is all of physics. So if
No,
you're,
it's not all of physics, bro. We done talked about it's not science, right? You're measuring a geometrical object, right? It's math. It's not science. So when you say, I'm not gay, but sometimes on the weekends, right? You're speaking out of both sides of your mouth, right? So you need to say, yeah, you're right, and then think for a second. Pause for a second and think about what he just said, right? And then if you have like a yeah, but make sure that it like goes along and follows with what's going on, right? We're talking about this is empirical, and you're like, yeah, but sometimes on the weekends I see curvature. No, you don't. And we're saying that, this refraction thing, you can't prove it. Yeah, but sometimes I think about it when I dream. Come on, bro.
Okay, but the thing is, if you're gonna use the geometric model, you're right. You can't see more than 1.2 miles at 1 foot observer height. But if you're using like the actual model with all the confounding variables, like atmosphere, which plays a giant role in it, then you have to account for refraction, which helps the globe Earth.
No, that's the problem. You guys don't account for refraction, and here we have a PhD in spectrophotometry who actually tried to debunk us by looking at refraction and under different conditions, but he's not one of us, so you're just wrong.
Are you talking about Andrew Young?
And
if you're going to
just begging
claim
the question.
If you're going
I
to
don't
claim
understand.
refraction, then it's the burden of proof is on you to show us which refraction, how that mechanism of action works, and so that you have evidence instead of just this nebulous refraction. We're interested in the evidence.
Demonstrate it. Show it to us.
Yeah, but not only that, you're only going to be able to evidence light rays bending over a curved surface if you can first establish that they are traveling over a curved surface, which we've already established you can't establish.
No,
so
no,
it's a
no,
begging
no.
the question fallacy. Like
No,
you
no.
agreed.
Okay, I don't know which fallacy this is, but we're talking. This is like
So I'll give
changing
it a
up the
go.
entire subject. I don't know what the fallacy is, okay? But we are talking about you guys trying to break down the Earth model. You're trying to disprove the Earth
No,
model.
we're talking about reality, not comporting with the globe model as they're telling us. Right? They're telling us one thing, and reality is saying something else, and we're showing you that. That's it.
Right? No. You're trying to show reasons why the globe Earth model doesn't fit. But when I give
No.
an explanation for why it does fit, you
A
say
baseless
that's a
explanation that you're
logical
begging the
fallacy.
question. Yeah, because you're begging the question. Because when I asked you, okay, what curvature is it bending over? You said, I don't know. No one can measure it. So you're begging the question.
Wolfgang,
Yeah, what's up, Jenny?
for your convenience, I posted something for you.
Oh, thank you.
You're
So
welcome.
the question that it begs, if no one can measure it, then how do we know it's there? Do you see how the begging the question thing works?
It's
Oh
not
yeah,
there.
yeah.
It's
So
just a thing the Glober's made up. It's a made up bullshit story. Refraction does not exist. You can go out there and measure the Earth. It's flat. You can go out and observe it. It's flat. This refraction thing is something they just barely came up with about a year ago, and they just keep blah 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 with no evidence whatsoever for refraction actually existing, and they can't demonstrate it. They can't prove it. They can't do anything but say refraction.
yeah, let me just quickly
It's another one of
make
those
sure.
stupid jokes, dude. It's a joke.
Okay, it's cool. It's cool, God Rockin'. Smile. Do you see what Jenny's posted in the live stream? If you scroll up at 53 past the hour.
53. Oh yes.
Could you read that out loud for us?
An example of a begging the question logical fallacy would be a person stating that a fairy's favorite food is chocolate. Before they provide that fairy's favorite food is chocolate, they would first have to prove that fairies exist. If the person cannot prove that fairies exist, then the latter part of their statement is moot.
My unicorn needs to be fed.
Yeah. Okay, we get it.
Yeah, so,
Can I continue
if you're
reading?
Gonna say the reason. Yeah, sure, go for it.
Okay, to prove that they live on a globe, the majority of the person would have to present empirical evidence based on a method that is repeatable by the majority of people. Pictures, images, or video of a globe are not acceptable. Okay. I guess, okay, yeah, since they could be fake, that makes sense.
Mm-hmm. Do you want to keep going?
Not acceptable stories of Greeks. Computer models, I think those should be acceptable because
you live in
they
a
follow
computer model?
Huh?
Because you live in a computer model?
No.
Computer model could show anything. You could make a rhombus.
No, you're right. But if you keep the laws of physics consistent, then a computer model is the best way of determining reality without actually having
Yeah, but you
to...
can't model a world full of real-time physics accurately. You don't know what it is that you're modeling, right? You think you're modeling a curve, or you want to model a curve, but there's no reason to think there's a curve. That's the whole point.
Right. You'd have to model both. You'd have to model both of them separately, and you'd have to model a perfect world, like perfect geometry,
Dude,
Which
I
you
could
can't
make a
do.
perfectly working model, right, with Superman, absent of kryptonite, making a sequel bound over a building, right, like that 6-story building we just got through talking about. And the model can all work out mathematically, but does it work out in reality?
The laws of physics won't allow somebody as small as Superman to.
Right, exactly.
no, but if
You're gonna say there's kryptonite, right, in his underwear, and he can't do it, right?
Yeah, if you make a model that manages to predict Superman's speed at a given point, does that prove that Superman is real? No.
If
So
you
it's
if you
begging the
have
question.
laws, if you have consistent laws of physics with the real world, and then in your model you have a Superman, then all you have proved is that Superman could theoretically exist. You haven't proved that he does
Right,
exist.
if he was faster than a locomotive, more powerful than whatever, I don't even remember. But yeah, you
Right.
could model that out, and it doesn't have anything to do with reality.
But your only evidence for Superman would be, well, I put him into my model, and that means
Well, no,
theoretically he could be
through
real.
your model, you'd be proving that he could theoretically exist. You're not proving that he does exist. You're just saying that he
Right,
could.
but then you could put in unicorns, goblins, orcs, and everything else, and you could say, well, theoretically, then they can all exist, and it's equally smart and logical to think they could all exist.
As long
And
as
that's
they
what I'm
follow
going to
the
base
laws
my
of
worldview
physics,
on.
sure.
Yeah, but the difference is you're not basing your worldview on that. You are basing your worldview on this. You literally think you live on a spinning ball because of this idea. That's what you're trying to convince yourself of. If you plug Superman into a model and you tell yourself, well, theoretically, it means it could be possible, you're not going to be going outside looking up at the sky all day thinking, what if I see Superman now? Because I put him in my model. I mean, that's just, again, fallacious, ridiculous, nonsense thinking.
Yeah,
So we're
that's
talking about
true.
reality here. Yeah, so begging the question fallacy, you understand what it is. So saying refraction, the light is bending around a curve, is a begging the question fallacy because you have no curve.
Right, but
Right. That's it. That is it. We don't do logical fallacies.
I understand. Okay, if I'm trying to prove that the Earth is a globe, then I can't use refraction as a reason that the Earth is a globe, because first I would have to prove that it goes around a globe. But if you guys are taking down the the globe model, I
There is
am
no globe,
perfectly.
though. That's the thing, yeah.
Okay,
That's the thing. Because
okay.
if the initial assumption isn't proven or evidence, then we're not going to need to take down anything. There's nothing to take down. That's the point.
So then, what have you been trying to do all this time?
Well, we're trying to make people realize that the Earth is not a globe, obviously.
Right. Well, to do that, you have to start with the assumption that the Earth is a globe, and then give
Wait,
reasons.
is that what we're doing? No, you see, you provide evidence when you make a claim, right? And then you have to provide evidence to dismiss it.
So you're
But if
roboting a
you
little
provide
bit.
evidence, then we could just hand wave dismiss it.
Yeah, we couldn't
Let me
really
try and
hear
repeat
any of
that, Hank. You were kind of breaking up.
Hello?
He's
Hank?
going to rejoin. Give him a sec.
Okay. Anyway,
we
so
falsify the model. We falsify the model. That's what we have to do. A model has to be able to be both falsifiable as well as provable.
yeah, so if you're trying to disprove the globe model, what you first have to do is assume that it's real, that the Earth is a globe, and then give reasons why it can't be, because
Not if you're not falsifying it. No, you don't have to assume when you're falsifying something, you're disproving it.
That's
Yeah,
crazy.
yeah. So,
You
no,
don't
you have
start with the assumption that's fallacious to begin with. Sorry, just very quickly, if Damsel's here and Jenny's here, I don't know if KJ's here as well, but if you girls want to take over.
Oh yeah.
You guys
I
wanna speak
found
to
a
Cloud?
really simple meme for falsifiability. I mean, I've seen people use, like, I think the Wikipedia one, but I actually found this on a kid's site. And so I think it's better than what I've seen before. Because I think that, the average person, they're not familiar with this kind of stuff. Like what science is supposed to actually do. And they don't understand when we say, well, we falsified the globe. They don't know what that means. They don't know that means we found countless anomalies with the model, the heliocentric theory.
Right. Well, if I can continue with what I was saying, if you're gonna try to disprove something, one of the ways to do that is to first assume it's true. This is in math too, right? You first assume it's true, And
What?
listen,
Oh.
listen.
No,
You
that
first
is how that is
Oh, waste
a
of
begging
time.
the question fallacy. Any form of an argument where the conclusion is assumed in one of the premises is a begging the question and is a form of circular reasoning.
No, you're not
He
understanding.
hasn't finished his sentence. He's starting to talk about proof by contradiction.
Okay, yeah, let me just
Exactly.
we'll let Smile finish, but just very quickly, I'll just add this before we and let's try and hand it over to Jenny and Damsel if they're here, maybe KJ if she comes back. But so you're wanting to say, okay, but if we assume the globe and then we do, well, but I mean that is begging the question again. But that's pretty much what people have done, right? Most people went into this being like, okay, the Earth has to be a globe because everyone says it is. I'm just going to go and prove it's a globe. I'll go and observe this horizon and calculate where it should be geometrically, etc., whatever they've done. And then they've compared it. So they've assumed a globe, then they went and checked, and reality isn't matching. So it's doing the same thing whether you assume a globe first or not. But there's no reason to assume a globe. So Smile, with that in mind, you can say what you were going to say, and then let Jenny and Damsel and that take over.
I think whoever was talking before, they put into words exactly what I've been thinking. So what you're trying to do right here is a proof by contradiction, right? But if I can prove that that contradiction isn't valid because some part of globe Earth physics disproves it, then you haven't really disproved anything.
Right, but you didn't do that because you just agreed with us when we said that your attempted rebuttal is a begging the question fallacy. You've forgotten that point. You didn't have a rebuttal. It was a fallacy. The refraction rebuttal isn't a, if I have a point of physics that I can explain, then your debunk is wrong. No, you don't have a rebuttal. You have a logical fallacy, which by definition is not a rebuttal to anything. It's a logical fallacy.
If you assume Earth is true, or the globe model is true, in
Why would you do
order
that?
to proof by
See, that's
contradiction.
not science, though. You're saying
Right.
assume.
Thank you, damsel. I was wanting to say that like
You
a
keep
minute
saying
ago.
assume. That's not the scientific method. See, science is a method. It's not where you can make
Whatever you wanna
assumptions.
do.
You have to actually put together a logical series of potential events, and then if they are falsified, you're done. I mean, you know the model is not right, and it doesn't have to be over and over and over. You just have to start falsifying even one big part of it, like there's no curvature.
You're right. So if you say, okay, the geometric horizon should be 1.22 miles away at observer height of 1 foot, and I say that doesn't work because the globe model says that doesn't work because of these reasons, then you haven't disproved anything if you're trying to disprove it.
Your model doesn't say that. You made another assumption. See, you assumed that your globe model doesn't say that. We have absolute statements made by your model, and we are falsifying those statements to see if it was true, and it's not true.
You can't take the statements. You can't take the statements one by one. You have to take either the whole globe model or none of it. You can't
Sorry,
take some
but
parts
your
of it.
globe model requires everything to work perfectly to get your equations to work, and it doesn't.
Right. So if it's a bigger ball, everything comes crashing down like a house of cards.
And your globe model is inherently contradictory within itself. It has no working complete model. It's just a bunch of ideas hodgepodge together and exist only within your mind.
Maybe that's true, but maybe it isn't. Look.
Well, see, you just have that maybe because you haven't actually gone out and done the evidence and looked for these things. You think
Only
you
reason
know
you
what your
believe it-
model is. Too.
That's pretty
Yeah,
cool.
you think you know what your model even is, and
Okay.
that's the funny part is that you
Yeah.
actually don't know your model very well. You think it can do certain things that they claim it does not do, but you make an assumption that it must have worked out. Somebody's got this figured out, or I think this is, or you even blend what you see in reality and think that your globe model matches that when that's probably not even true either.
Okay, do scientists claim that refraction in the atmosphere doesn't happen? No, they don't.
Do we claim that refraction in the atmosphere doesn't happen? No, we
We
don't.
claim that. That makes you a flat earther, by the way. Well, like
What?
refraction. Because your model claims that you have a physical horizon. So you don't understand your model again. So you just claim to be a flat earther right there when you said refraction without even knowing it.
Damsel, I so happen to have some visual aids if you'd like to go in depth more of what you just said. Hold on just a second and I'll pass it along to you.
Time to split. I said, don't you
It's
fucking.
there's screenshots from the investigation into the Black Swan that Karen B did. Hello?
Taking a look.
Wonderful.
Hold
Yeah,
on, I got it.
there goes. I see what you're looking at. The question is he looking? Elliot, right? Am I right?
Well, here, I put them all on one web page, and whichever ones you want to use, just post each individual one. Or not. I mean,
Well, you can keep talking while I look at them because I haven't looked at this one.
yeah. I'm sure once you look
Thanks
at
for
it,
posting it.
it'll be very familiar to you.
Probably, I probably actually worked
I'm
through
not
these
as
and put
I'm not
together.
as I'm not as well versed as Damsel is. I mean, I have been actually doing some more study on it. Because I mean, it's one thing to realize something, but then it's a completely another thing to understand it and actually understand it well enough to describe it to someone else. So, you know, do you really have knowledge if you can't describe it to someone else? I mean, yeah, I mean, I guess is there value over other knowledge, but I don't want to keep rambling with that. But yeah, so she's going to be going back to, you know, some very specific terms about the geometric horizon versus an apparent horizon. And that would be due to perspective. So, yeah, you know, what you think you're seeing when you're looking at the oil rigs. I mean, do you think that the horizon is behind the farthest oil rig? I'm sorry, I don't know who the new person is that we're talking with tonight. I'm sorry.
Smile.
Yep, I'm still here.
Wait, what's the name again? I didn't hear that, Hank. Sorry.
Smile
didn't
Death.
let me post Smile Death. Okay. What a lovely name. How cheery. Okay.
I made it when I was playing games.
Okay, so maybe I should not use the oil rig as an example. Like if you're just sitting on the beach and you look at a ship and
They said my name and I have no idea why, and it's so stressful because I was like, what the fuck, they said my name. Jesus Christ.
camera and you can bring it back into view. So, you know,
I'm sorry.
with known distances, that means maybe not with the boat, but with the oil rig, with known distances, that means we're seeing too far. Okay, you ready, Damsel?
Well, the problem is I tried to post the first image underneath the Black Swan because it explains what the Black Swan is, and I just didn't get it. It didn't work.
So, it should be okay. So
Copy the image didn't work. I'm trying to
Oh,
figure
well-
out what to do.
Oh, hold on. I'll tell you. You should be able to. If you touch the image and then there's a share button, I thought it's an arrow.
Let me try.
Okay, wait, copy. Let me see which one's copy. Shoot. Okay, I didn't think about this part, dear. Sorry. I'm looking at it right now.
No worries. No worries. Did he?
Oh,
Have you
there's a
looked at?
download.
Have you looked at the Black Swan image before?
Oh, me?
Yeah. Since you're
Yeah,
here.
I've seen it posted
So,
multiple
what
times.
is what's your impression of the argument and what you're seeing? I would like to hear your description of what we are showing you.
So you can see the two oil rigs, I think they are. You can see them farther than you should be able to see them, right?
No, it's not about the oil rigs. The oil rigs are just being used as a distance marker for the horizon that's physical.
Oh,
That
okay.
your
Wow,
model
that's the
claims.
first time I've heard that. That's amazing.
That's the way this works. Those are mile markers so that you should know where the horizon should have been or is too far already. That's why we always ask you to look at where the horizon is. And you should be able to tell me where it's at. Is it in front of the oil rigs, middle of the oil rigs, or behind the oil rigs?
Damsel?
Yes, ma'am.
Are you on a phone or are you at a computer?
I'm on a tablet.
Okay, so when I long press, I use Google for my browser, and then it says share image at the bottom. Or if need be, I'd be happy to accommodate and post whichever one you need.
Yeah, I think I'd like to post the first one down that actually says, what is the black swan, I think.
Okay, I'll do that.
First, it's like the first one after the title.
Okay. Just un momento, por favor.
I'd like you
There we
black
go.
swan image again, and then I would like you to read what is the black swan so you can kind of maybe understand what we're doing.
Okay,
Because
no,
if you
I
didn't
understood it.
understand, yeah, if you didn't get how this doesn't matter what the oil rigs even really look like. It's not about that. It's about where the horizon is in comparison
I
to the
will.
distance.
I very much appreciate all of the work that Karen B did this for this video and all these screenshots that I have. But I have to say that I'm not really comfortable with how she worded her black swan. What is the black swan? So I actually, no offense to her because she puts in a lot of time with a lot of stuff, way more than me. But I'm kind of looking at kind of collaborating and wording it different.
You could probably get it a little sharper, I'm sure, but she's got the
Yeah,
general
yeah.
impression, and it may work better for some people than others
Yeah,
too. So you can
yeah.
always improve on stuff. There's nothing wrong with that.
Yeah.
So.
So I just want to put that that in case he reads it and then still like, oh, what? So okay.
So
Go
the
ahead.
argument has to do with the R value that they've given us. You know, if that R value is incorrect based on the fact that they claim that there had always been a physical horizon, because even you know, when you were told in school, when you looked out over the ocean, you were seeing what? The physical horizon. You were told this all the time, all your life, and now you're trying to claim refraction, which is what we say is the natural thing, because the horizon is actually apparent. It moves during the day. If you actually watch the video of that particular picture of the black swan that we have of the oil rigs, you will see it fluctuate throughout the day, and every day you go will fluctuate different. And we see this on all kinds of horizons, whether they be over water, whether it be over land, sometimes depending on the moisture in the air, dryness, all kinds of conditions. So that's the
Wait,
question. Is
I'm
your
pretty sure.
horizon a radius? If you don't have the radius, you don't got a globe.
Yeah,
Yeah.
that's one of the fundamental parts of the globe. I think the tide or the horizon increasing and decreasing is the tide.
It can
But
be sometimes, absolutely. But other times you're seeing so it can't be that, because at 1 foot observer height, how big does the tide have to be? Just
well,
waves is what we're talking about.
well, the tide increases by a lot. It's like 10
Except
foot.
for
Wait, is it?
you can go on days when there's no tide and still see too far. So how do you explain it?
Oh, I thought we went over this, but I guess you weren't there. Yeah.
No,
Okay.
I wasn't there.
Yeah, I know.
What's your proof that that's somehow important enough to change your horizon distance and not give you the proper R?
R is refraction.
No, R is your radius. If you
Oh,
can't
okay.
prove the radius, you don't have a globe of a certain size that they claim they measured at a certain size, which then your whole universe is based on that R value, by the way, and so is all your space.
The whole
Everything
universe is based on the
hinges.
R value.
Yes, because your Earth is a certain size in the universe system. And if it is a different size than what they claim, then all the mathematics that you keep claiming prove everything are a mess.
And then, do you know anything about how the radius was allegedly measured?
Yeah.
Okay.
I can think of 2 different experiments, but
Okay, see, but the thing is
tell us what those experiments are, by the
it
way.
wasn't a direct it was he declared the Earth's radius by observation of the height of a mountain, the topography. And then
yeah.
he did like a bunch of calculations and stuff. That's not measurement.
It's also not an experiment.
Well, it's indirect measurement, right?
Okay, but that's not how I want to base my reality, and that's why we're all here.
Well, if you're trying to
That
directly
that
measure
doesn't.
the Earth, you kind of
Yeah.
can't.
No, you can. See, that's the thing. You think you can't because they told you over and over somebody did it. So you tell me, well, somebody did it. You'll give me Aristophanes probably and this
Nope.
other guy. And then you'll tell me, yeah, that's how they got the art. But then you tell me you can't do it. You
I
understand
can
how
do it.
conflicting that is?
No, I can do it
How? How would you do it?
the same way they did it, right?
Well, you have to explain to me how Aristophanes works. And keep in mind, that's not an experiment either.
No, you're right. It's not an experiment. It's just a measurement.
That's right.
Damsel, I just really quickly before you continue,
Or an
I wanted to point out that Wolfgang wanted to give us a heads up that.
No, he's
Uh,
gone now, Jenny. Don't worry about it. Carry on.
Okay,
He was
never
just being
mind. Please,
salty.
okay, go on.
Golly,
Yeah,
broke my rhythm. No. No, but again, explain to me Aristophanes and how that proves your globe. If you
It
can
doesn't. No,
explain,
no. So I've gone
well,
over
how
this
it
multiple
gives you
times.
it gives you what though? What does it give you?
It gives you your R value, but his entire experiment was based on the assumption that the Earth is already round. So that's not okay.
It's not
Well, it's not
science.
experiments. It's not experiments, so it's not science, but it is an observation. The problem you have with that particular observation is you make assumptions that you have a distant sun with parallel light rays. Did you know that if you had a flat Earth with a closer sun and divergent rays, you'd get the same results with your sticks?
Yeah, I know. It doesn't work.
What?
I've already-
You would get a flat Earth. It would work on the flat Earth as well. You'd still get sticks and shadows with the same kinds of shadows. You don't
No,
get a
I know.
change.
I've gone over this before with other people and that's why I don't use it anymore as like a proof.
Right, because it's not anything. But yet they based your whole R on that, and they actually made a bunch of other assumptions based on that. So now that's blown away. So where's your R from? Where are you getting your R?
Look, so I went over this with somebody else also, but knowing that the Earth is round and measuring it are two different things. You don't have to measure it to know that it is round.
What?
How would you know it's round if you can't observe it or measure it? How would you know?
You can observe it. You can't measure it.
You can. Where did you observe it? Where did you directly observe it?
Me directly?
Yeah, because this should be something you can do.
Well, you can't directly measure it or directly observe it. Sorry. Look, the Earth is too big. You can't go up in a spaceship and do it yourself unless you're Jeff Bezos.
So you have to trust 23 men who say that they went far enough so that you could see it all together. You have to trust them, but you won't trust high altitude balloons that you could send up yourself that show a flat horizon.
Well, you have to trust the entire organization of NASA, and I'm pretty sure there are examples of hot air balloons.
Which is what logical fallacy?
That's yes, that's appeal to authority. Except, I think it's okay to appeal to authority when there's thousands
want a
of
real-
people.
If you want a religion, it's okay. That's true.
No, I
you
mean,
want a
when there's-
religion, but it's not science. That's not science.
Well, when there's
that's not
thousands of
evidence.
people,
No, you're saying that that's evidence and science for you, but it's actually faith and religion.
I don't think it's a religion.
No, that's what a definition of a religion is. You follow some leader that tells you it's such and such, and you just believe it.
Who's the leader?
Well, it'd be NASA in your case.
NASA
That's a
isn't a
whole
person.
other talk show.
Science, it's science, this thing called science that supposedly some people know more about than you do.
I hope you realize
then
there's
have to have
other.
faith in. Then you have to have faith in. See, it is a religion, whether you want to admit it or not. That doesn't matter to me. It's just the
Yeah.
truth of the matter.
Except I hope you realize that there's other space organizations.
Yeah. And have you seen some of their evidence, like their movies and photographs? If you believe that, well, you, like I said, you got a lot more faith than I do.
Ditto.
Who's pinging me? Oh.
we here do not trust other men. We trust what we can measure, observe ourselves, and confirm for ourselves. Because again, if you want a religion, you can have it. We're fine with you keeping your religion. That's fine. I'm not going to try to convince you or convert you. I have no desire, and I don't want to promote a religion, so I won't tell you what to believe. I will tell you, seek the evidence, look for measurements, do things you can actually confirm for yourself. Then you're not believing you know. I would rather you know things.
Okay, Hank, yeah, you're right. I'm just looking for the truth. Okay,
Which
here's
is good. I'm glad you're here. You're asking the right questions and you're actually doing really well. So don't think we're trying to diss on you. I'm not. Like I said, you can keep your
Okay.
belief system. It's okay. But
Yeah,
keep in mind, you're here to debate that belief system with what we know. Okay,
Mhm.
so there's a difference.
So why do you what? Okay, yeah, go ahead.
I was just gonna say, she's kind of just telling it like it is. So, sorry, that's just my 2 cents. Thanks.
Yeah, that's good. Look, the thing is, I've been in the server for like 2 or 3 months now. I only joined the past 3 live streams, but what I'm just gonna ask you a question. So why do you think that I haven't changed my mind the entire time? Do you think I'm just do
No,
you
I
think I'm
didn't say
just
that. I make no assumptions, my dear. I
Me
really
neither.
don't. And that's
We
why I
don't.
said you can keep your belief if you want to. Did I say you have a belief for sure, or that it's your religion? No, I said it is a religion. If you do
Part of
that,
it. Part of the foundation of this server is that we don't challenge each other's beliefs. It's a journey for everyone, so you'll come about the information when you're ready.
Mm-hmm. But why do you think I haven't changed my mind at all? Do you
Because
think
you're
it's
not
just
ready.
because
because you haven't said anything that makes me for sure that you have changed much of your mind, other than you gave up Aristophanes. Cool.
No, I gave that up as a proof. I still think that it.
That's right.
Yeah, I realized in hindsight that was kind of stupid.
No.
Then why
It's
is it
called
one of the best
logic.
proofs on the internet?
It's your
Well, it's 'cause
logic
people.
finally getting the better of
And
you.
to be fair,
You're
it took me like
doing good.
2 to 3 years to change my mind, so I'm not impressed you don't change your mind yet.
I mean, I think the reason it's one of the biggest proofs is because people don't have a good understanding and
Yeah, because we're all
visualizing.
incredulity. We're all stupid. We don't understand the globe model. Even though that you're coming in here and everyone here will run circles around you when it comes to explaining the globe model.
That's literally not even what I said. I said globe earthers don't have a proper understanding of the flat Earth. Thank you, though.
They don't understand this. They don't understand the globe either.
That's the biggest problem is you don't know your own model very well. So you have a hard time then disproving it because you just believe and you think everything's been figured out. And that makes it really hard because if you think you know everything already, you don't question. That's just what happens. It's normal human nature.
Yeah, but I mean, I've been given a lot of facts by a lot of people, and sure, they're all true.
The reason that you don't know the flat Earth model is because there isn't a flat Earth model. That's why no glober knows it. And every time a glober asks for a model, they haven't actually got their own model, so it's stupid. But yeah, continue your painful process.
We don't need a model. We don't have to replace what we falsify.
No,
We
I'm not
like
looking for a
reality.
model.
We don't need to live in a model. We live in reality, which isn't known well enough to give you a complete model that would be perfect enough to be called a model, because a model should be perfect representation of reality. Yours is not.
Well, no model is the perfect representation of reality.
But that's what is required.
You can never have a perfect representation because there'll always be more to know.
That's why we don't use models. We don't need them.
Well, you should still use models.
That kind of
Just the ones
model.
that
I mean, we can use models for other things, but we're talking about this, your reality. Yeah, you can model parts of it, but don't call it a whole model. It's all working and everything works with Newton and Einstein, and when they both contradict each other. I mean, it's just your model is a mess, an absolute mess, but yet you guys cling to it saying like it somehow works. It doesn't. See, that's the thing. You made another
They
assumption.
ain't even got a they ain't even got a model. They talk about Google Earth. Google Earth shows no curvature rate, curving at the rate of that's descriptive. They haven't got an actual model. What they've got is different sorts of descriptions of a model that explain one criteria at a time, such as refraction or a model for this or a model for that. They haven't actually got a complete model. So it's so stupid when they ask for where's your model. You ain't got one yourself.
When you buy in
But
the
you
shop,
want us to replace you one. You want one so bad, you got to have a replacement. Oh, it's so bad. It's just funny. I mean, I thought the same way back in the day. I would have thought this too before I figured this out. But
Replace
it
what? They haven't
really
got a
comes
model.
down to
Replace
knowing.
what? Replace what? They haven't got a model to replace.
No, I don't got one to replace.
got
I just
one in
like
the first
reality
place.
now. I love reality.
give me my model.
Give it to me. I need one. I need it.
Yeah, but the thing is, like, I've been
Can I?
presented with so many reasons why the Earth isn't a globe, right? But why do you
And
think I haven't accepted any of the reasons or even thought about it more? Because I have my own reasons for saying, wait, that doesn't work. That's not a valid contradiction.
No, it's very fair enough. You know you've got to continue exercising them thoughts until you know there's no doubt in them. But the thoughts that you have had, they're very primitive, and you know the usual. The reason we still have monkeys is because they evolved from Homo sapiens. We never evolved from monkeys. Like a lot of globers feel like that flat earthers misunderstand this simple concepts. But they make it simple. They say like, "Oh, we grew from monkey," just to patronize you. It's not because we don't understand what you're trying to say. It's because you don't understand what you're saying. You're saying that fish can turn into human beings. You're saying that the Earth rotates, and it literally experiences it as if it doesn't. Everything operates as if we're in a contained system that's not moving. But yet we're led to believe that the moon's rotating, the Earth's rotating.
Moon's
And we
not
don't
okay.
experience
Well, the moon.
Coriolis because of the conservation of momentum. It's just constant bullshit.
Oh yeah, wait, I haven't talked about the Coriolis effect. How do you guys explain that?
Well,
It's
you live in a contained system that behaves like it's a contained, non-movable system, and apparently it's moving, but it's not, and there's no way to detect it.
Right, but how do you explain the Coriolis effect?
Well, tell me what the Coriolis
Can-
effect is.
we
Since you
cannot
seem to
detect
think it explains something, why don't you tell me what the definition of it actually is?
Okay, well, I'd have to use the globe Earth model, but
Well, yeah, that's what I'm asking you for, because Coriolis is not what we claim, it's what you claim. So you tell me what the definition of it is.
it exists. Okay, yeah, hold on. Okay,
I didn't
so
say it exists. I said that's in your model.
I know. Okay, so the globe Earth model says that because the Earth is a globe, different parts of the Earth move at different speeds. So, for instance, if you're standing at the poles, you'll be turning on the axis, but you won't be moving. What?
Oh, sorry.
We've heard it all before. That's all.
She just knows how
Sorry, man.
difficult
I
this
didn't
We've
want
heard
to
it
be
all
rude.
before. It's like 10
Heavy
years old.
sigh from Jenny. Look, guys, let's let Damsel carry on with this conversation for a minute. Finish your point, Smile.
Yeah, go for it. It's all right.
Okay.
Don't
So
worry.
different parts of the Earth move differently. So that you when you're for instance shooting something across a really long distance, facing south to north or north to south, you have to count for that.
Really?
Yeah.
Right. Could I have somebody post the Coriolis going on a merry-go-round? Does anybody have that one? And then the definition, the actual definition.
What?
Does somebody have the merry-go-round with the Coriolis effect? There we go. And then if somebody has the definition of Coriolis, so I don't have to go hunt it down right now.
I can't spell Coriolis.
So do you see the image above where they are on a, it's showing you on a flat plate that's spinning?
Yeah.
Is the object being thrown across the outer edge actually curving or
No.
not?
Well, it depends on your reference frame.
Oh, it depends on your reference frame. Huh. How many reference frames are there?
2. In the first reference frame, it goes straight, and then the second one, it curves. It's doing the same thing in both. It just looks different from where, depending on where you are.
Yeah. So the plane do that. The planes do that. The planes behave like that. Do you get two different reference
Exactly.
frames from looking at a plane?
So does an airplane curve? Does it
The like
actually
flights?
deflect? Is it actually not going straight even though you see it? Do you see it
Yeah,
in two different
airplanes
reference
curve.
frames? No, I mean from the Coriolis only. And do they move with what reference frame? Which one?
I don't know. I'm not an expert on aviation or.
Yeah, well, they don't seem to be going any faster when they go with the direction of the spin or against it, do they? That's more air currents with jet streams that
Yep.
affect it than anything. But you
Yeah.
got Neil deGrasse Tyson telling you somebody kicks a football and it deviates to the Coriolis, but yet an airplane or a hot air balloon, none of those things do. Or a bullet supposedly does, but yet a helicopter doesn't.
Like I said,
Okay, well,
everything
I'm not.
behaves. Sorry, go on.
Well, I'm not an. Okay, yeah, you go, you go.
I was going to say that everything behaves as if it's in a closed system that's not moving. Everything behaves identical to as if something's not moving, and you're only led to believe that you do have this Coriolis effect when things leave their separate reference frame. Like you should see the plane curving away. You don't see any of this behavior. There's no way to identify the things that are happening on the globe, because apparently there's reasons why we're not expected to see that, or they're factored out, or it's negligible.
Alright. That was my live stream. Those are my research. That is my research, sorry. I'm just gonna close some things up. I'm gonna check up on, play a quick game of Minecraft just for fun. And then, let it be, I guess. Alright. Just give me a sec to launch up the game. I'm gonna be right back on for a sec, just for it to properly play. Alright. Now I can put the live scene back on. There we go. Should be able to work now. Just give me a sec to figure out why it's not working. Do I have to put it in F11? Ah, yeah, there we go. Okay, can't be full screen. Okay. Alright, let's play some lab first. Alright. Boy, go ahead. Let's go. Oh, why am I lagging so much? Oh, it's the stream. Can I F11? No, I can't. Shit, I forgot what we were doing. Alright, that was really embarrassing. Truly, truly embarrassing. Alright. It looks so laggy on my screen, but not on the live stream, so that's annoying. I'm having trouble focusing on it. I'm gonna go to sleep after this, or just chill in my bed, because I know I can wake up at whatever time I want. Oh, I'm too laggy for this shit. I'm too laggy for this shit, bro. I don't know what's happening. It's actually frustrating me a lot. I think it's just my computer's a little tired. It's time for me to turn it off. Please tell me everything else sold. Oh, 500 coins. Are you oh my god. Fuck that. Okay. 2.3 million for 9 days left, 7 days left. 6 hours and 55 minutes for a warden helmet. I can't afford that bit, can I now? Oh, I can't. Yeah. Alright. Guess I'll go to bed. Alright. I don't know what I'm doing now. Oh. Of course it's gone. Oh, it's gone up. Right, okay, it's gone up. Alright. To sleep I go, man. I'm really tired. Alright. Yeah. Okay.
And to my subscribers. As some of you already know, I recently stumbled onto 15 separate official NASA documents that outline the various aspects of aviation, complete with formulas, calculations, and conclusions based on tests conducted.
It's interesting because it's only all of these are deleted. There has to be deleted. I mean, I'm not trying to be a dick. I just mean like there are 45 dislikes. There has to be some hate comments because usually haters are louder. Oh, okay. Let me just send this to Robin before. Alright. I wish I got something better than VC verified, like seems legit or something. Wow, that's a lot of people for a thing like this. I don't know, man. I don't know. Alright. Source, trust me, bro. Proof this is real. Okay, this guy is kind of annoying. I kind of agree with Xander on this one. Interesting stuff, man. They got deleted. Okay. Alright. Oh my god, dude, there's nothing said in this. And it's unclassified. It's not fucking important. You're joking, right? I'm sorry, I don't want to end my stream like this. Obviously, I've been doing a lot of research on Flat Earth or listening in for a good 3.5 hours or 4 hours. So, but this just, I don't know. It seems, yeah, I don't know. Anyway, to everyone watching this, I hope you have a fantastic night and that you enjoyed watching me not say anything for 3 hours and just listen into to a live stream. And me insulting flat earthers. Like, I don't mean it, obviously, but yeah. Like, I mean, I don't know. I don't know what I like. Obviously, I believe that the Earth is a globe. It's just annoying that these people are so stuck up about it, I guess. All right. Much love to everyone.